Okay, so welcome to Doing Terrible Things with ruby.wasm. Well, first of all, who am I? Well, I already introduced myself in the city pitches, but if you missed it, my name is Matthias, and I'll also answer to Matt. And you can find me on all the usual places, like Mastodon and on the internet, where most people can be found. And as my day job, I'm a senior developer at a company called Venue, where we do bookings for event spaces and other event services. So, for example, if you're organizing the next Euruko, you can use our service to find the venue. Or maybe you're organizing a meetup, or a wedding, or a birthday, or a company offsite, basically anything. You can go book a space from us. I'm also one of the co-founders of Helsinki Ruby in Finland, which is a nonprofit where we promote Ruby and other software development stuff. And you might know us from last year's Euruko in Helsinki. And this is the pitch I already gave earlier in the city pitches. So, well, yeah, we're doing something different this year. It's O the Humanity. It's a human-centered software developers conference with a keynote from Anil Dash. And as mentioned, you can get a 20% discount of tickets. Or you can just go and scan that QR code there. That works also. But yeah, let's get back to the topic on hand. Doing terrible things with ruby.wasm. Let's start out with some basics. Who here knows what WebAssembly already is? All right, about half, I think. Well, it first appeared in 2017, and it became an official standard in 2019. And if we consult MDN, we get this wonderful wall of text. But it boils down to it's a low-level, assembly-like language with near-native performance that provides languages such as C, C++, C#, and Rust with a compilation target so that they can be run on the web alongside JavaScript. And you'll bump into two different WebAssembly file formats if you start looking into it. The first is WHAT, which is the text representation, which looks like source code. And then there's WASM, which is the binary representation that everything else gets compiled into. And the WASM files are what actually get loaded and run in the browser. So, how do you WASM? Let's first look at some plain WebAssembly, or plain what. So we'll look at an example where we add together two integers. It looks something like this. So it's a little bit verbose, but it's readable. We define a function, we take two parameters, both are integers, and we return a result, which is an integer. And in Ruby, this would look something like that. So it's slightly more verbose. But if we look at a bit of a more convoluted example, like checking if a number is prime or not, it gets a little bit more verbose, and we might not actually want to read all of this now. And for reference, this would be the same thing in Ruby. So, in my opinion, what is not just a file extension. It's also what you say when you have to read WebAssembly code. But as MDN says, it is not primarily intended to be written by hand, or, as I put it, it is not to be written by hand. But anyway, we now have our what file. How do we convert it into a WASM file? And there's a project called the WebAssembly Binary Toolkit that contains a tool called what2wasm. And there's an online demo for it, so you can do it right in the browser as well. But realistically, you'll use the command line interface. So now we have our WASM file. How do we use it in the browser? So here's a sort of basic example, and we can focus in on the script tag there, which contains the sort of meat of it. We have a little namespace set up there, and then we fetch our WASM file and initialize it. And once that's done, we can call the add function to add 1 to 2. And then we show an alert showing the result. And we get this very exciting page. And we do, in fact, get, now we know that 1 plus 2 equals 3. And it was very high performance. Yeah, that's sort of a stupid example, but the sort of things that WASM enables in the browser are kind of exciting. For example, Wavacity, which is a WebAssembly port of Audacity. It's a full-blown multi-track audio editor that runs right in the browser without needing to download anything. Or maybe you'd like to re-encode some videos. You can do that with the FFmpeg port, the WebAssembly port of FFmpeg. And you can do that right in the browser as well. Or perhaps something that a lot of people here might have a need for is doing some image processing. And for that, you could use the Photon library to do your image processing in the browser before the photo gets uploaded anywhere. And of course, Try Ruby now also uses the WebAssembly build of Ruby, which brings us rather neatly to ruby.wasm. So this was added first in Ruby 3.2.0, and it brings a WASI-based WebAssembly support. And here we get one more W acronym. So WASI, the WebAssembly System Interface, which provides access to sort of operating system-like features in the WebAssembly environment. And while we're swimming in letter soup here, I might as well introduce WASI VFS, which we'll bump into later, which is a virtual file system layer for WASI. But yeah, how can we use ruby.wasm in the browser? I think the simplest example is something like this, where we just load the library in a script tag, and then we can have Ruby script tags on the page, and they work. So this will print hello world to the browser console, which is, of course, very exciting for everybody. Or we can do something a little bit more elaborate, like doing interop between the JavaScript side and the Ruby side. So here, we do some setup code. We fetch the WebAssembly runtime for Ruby. We initialize it, and then we get access to a Ruby VM, where we can write whatever Ruby code we want. Plus, we also then can eval JavaScript code inside the Ruby code to interact with the JavaScript side. And now we get something a lot more exciting, where it actually prints something in the browser, not just the console. And then it's also possible to use ruby.wasm outside of the web. For example, here's the example that I ripped off straight from the README. And we can break it down a little bit here. Well, first of all, we fetch the WASI build, sorry, the WASM build of Ruby, and then we can extract it and create our own little app code. And then we use the aforementioned WASI VFS to pack it all into a single WebAssembly file. And then we can run that on the command line. There are a couple of limitations in the WebAssembly build of Ruby. First up, you don't get threads, which is, a blessing and a curse. And you also don't get networking at this time. I think both of these are being worked on, but at the moment, you don't get them. So that should be enough basics for now, and it brings us on to my terrible ideas. My first idea was to use something called wasm2c, which is also part of the WebAssembly binary toolkit, to take the Ruby WebAssembly implementation and compile it back into C code. So if we look at our add example from the beginning of the presentation, we can take that, use the wasm2c tool to convert it into C, and we get a header file, the .h, and the actual implementation, the .c file. And if we look at the header file, it's a little bit verbose. There's quite a lot of boilerplate, but the sort of essentials of it are quite simple. There's just the add function with a couple of prefixes that get added automatically. But if we look at the implementation side, it's a little bit more verbose again. Remember, this is adding 2 numbers. So it might not be the most efficient way. And in fact, it doesn't fit on this. Oh, it disappeared entirely. I was going to say it doesn't fit on the slide even if we use 2-point text. But, oh, it doesn't render at all in there. It fits if we rotate it 90 degrees. That was the point. Oh, and we also have to write some glue code to use that function. So we need to set up the interpreter and do some cleanup afterwards. But the sort of main part is there where we call the function and we get a result printed. And if we compile that, and also the WebAssembly implementation file is included, we get a binary where we can, once again, add integers together. But yeah, like I said, it's not the most efficient file. It's a 52 kilobyte binary that adds 2 numbers. But yeah, back to Ruby. What does this have to do with Ruby? Well, I figured I could take the my Ruby app WASM we created earlier and just compile it to C. And that part actually does work fine. It runs, we get C files out of it. But where it breaks down is if we try to compile it, we get a whole bunch of errors like this. It's all missing symbols. And, well, crap. Or rather, WASI. Because if we look at the WebAssembly binary toolkit on GitHub again, we find this little gem there. WASI support is still a work in progress. Only a handful of syscalls are supported at this time. And actually, it also doesn't support everything in the WebAssembly binary toolkit, so the WASI to C part of it doesn't support any of it. But hey, back to the drawing board. I didn't become a senior developer by not having terrible ideas. So, first up, Deno. If you're not familiar with it, it's a sort of next-generation JavaScript runtime. And crucially, it supports compiling scripts into executables, which sounds like exactly the sort of thing I want. So we could take our WebAssembly code, wrap it in a little JavaScript script, and compile it into an executable. So let's try that. Right. So here, we port the VM from NPM, and then we do some setup to initialize it, and we should be able to eval some Ruby code. But alas, once again, we run into some more incompatibilities. Well, no Deno then. So, how about Bun? That's the new hotness on the JavaScript scene. And if you don't know what Bun is, it's a sort of JavaScript runtime and package manager and bundler all wrapped into one. I mean, it doesn't actually support creating those static executable files, but at this point, I was desperate for anything to work. So with some small tweaks to the earlier code from Deno, we can try this again. But, or we can try. It doesn't work. Because if we try and log this method from WASI called initialize, can anybody guess what this returns? You might have undefined, your old friend from JavaScript. And actually, if you look at the Bun docs, we get this delightful partially implemented. It doesn't say which parts. So apparently not the parts we need. So no bun either. But hey, we're not out of terrible ideas yet. If we rewind right to the beginning of this talk, we already ran Ruby outside of the web. So it must be possible. So what in the devil is this WASM time? And no, it's not hammer time. It's a fast and secure runtime for WebAssembly. And it sounds like exactly the sort of thing we want. It runs WebAssembly code outside of the web, and it can be used both as a command line utility, as we saw earlier, or as a library embedded in a larger application, which is the sort of thing I want to do. And what's more, we don't actually need to write C here, which is a big bonus. And there's even an example that basically does what we want already. So we can take that example and adapt it to load the Ruby WebAssembly runtime. And if we zoom in a little bit, first of all, we import some required libraries, and we do some setup code to get the WASI stuff set up and configured. And then we instantiate the WebAssembly we compiled earlier. And then we call our function. And that's pretty much all of it. It's, I don't know, but 20 lines of code or something. And if we try to run it, it works. I mean, there's a few downsides. For one thing, it's about a 50 meg binary. And that seems quite a lot for a Hello World program, but I'll take it. And to put it into context for everybody of a certain age here, it's about 35 floppy disks. It also takes a bit of time to get going. It's just a hair under 3 seconds to run it, which is, not ideal. So yeah, it's a bit slow. And if we run a little benchmark, here we just have a sort of recursive Fibonacci benchmark. And we can compare plain Ruby 3.2, where it takes about 15 seconds or so. So with the WebAssembly build, would anybody like to hazard a guess how long it takes? I heard 3 minutes. That's quite close. It's about 2.5 minutes. But it works. And that's good enough for me. I'll take a win. Yeah. What else could we do with this? I mean, remember this from a while back? It should be possible to do this in the Rust world as well. And what would that look like? I don't actually know. I ran out of time. Or, to put it in sort of textbook terms, it's left as an exercise for the reader. Or, to put it in a meme form, draw the rest of the fucking owl. So, should you use my terrible ideas in production? No. It was right there in the talk title. They're terrible. But 1 out of 4 isn't bad. I mean, if you don't count the performance problems and the huge executables. But it sort of feels like there could be something here or there. I mean, there's been a few attempts at building a static Ruby, like a traveling Ruby, if anybody remembers that. But they've all sort of petered out quite quickly, mostly due to some maintenance issues. So theoretically, this could be an approach to getting a static Ruby build for something like command line utilities or single-file executables or single-file deploys. It's just a bit slow at the moment. But yeah, I think that's all I had for the moment. If you want to try it yourself, there's a few very handy links I found. There's a great tutorial from Evil Martians on how to do WebAssembly. There's the ruby.wasm repo itself, and the tools, and there's also a repo for my proof of concept. And then finally, there's a talk from Ruby Kaigi, I think last year, by Yuta Saito, the creator of the WebAssembly port of Ruby. So you can learn more about how that was actually implemented. Yeah. Thanks.